Hello everyone. So section 4.3d, we are still working with logarithmic functions. We are now going to, in the previous section 4.3ab, we saw we saw different properties of logarithms and also how to use them, and also the conversion between logarithmic and exponential form. That is very important. In section 4.3c, we saw how to graph the logarithmic functions. And now we are going to look at how to find the domains of the functions which involve the logarithmic function. So this topic or this concept should not be new, because we have done problems like this in chapter 2. But anyhow, so finding the domain of a logarithmic function, so to find the domain of a logarithmic function, we set the expression inside the logarithm to be greater than 0 and solve the inequality. Remember to use the sign chart if the inequality is non-linear. Okay, so let's look at the first example. So this is saying f of x is log base 5 of 8 minus 2x. We have a logarithmic function. What we do, we take the quantity inside and set it greater than 0. And solve. Now in order to solve it, it's your choice. You can subtract 8 from both sides. So you'll end up getting you have to simplify, you have to divide by -2. But remember, putting the -2 over here and then trying to write over here like this is wrong. As soon as you put the -2 here, in other words, you are dividing by the negative, you have to change the sign. Then it is correct. In order to simplify things, what I do, when I have a situation like this, instead of subtracting 8, I will add 2x to both sides, so which will give me 8 is greater than 2x. Now I divide by 2. 4 is greater than x, or x is less than 4. Always in the end, your statement should have the x on the left. Now remember, the question is saying state your answer in interval notation. Even if it doesn't say, you must give the answer in the interval notation, not leave it like this. So the domain minus infinity to 4. Okay, the next expression, well, then it is g of x is equal to ln of x minus x square, where ln means logarithm, natural logarithm. So this is also a log problem, so which means we start by taking the x minus x square and we have to set it greater than 0, and we have to now solve it. Now as soon as you wrote it, you must notice that this is a quadratic inequality, so it shouldn't be solved like a quadratic equation. What we need here is a sign chart. So I will first factor. Now we do need we do need the zeros, and zeros we get when we are setting this in this expression to 0, but we can write it like this. These are the 2 zeros which we are going to put on the number line, and I'll put my factors here. choose a test point, plug in, choose a test point in this region. It gives me positive and positive. Then I pick a point in this region, for example 2 or 3, positive and negative. So multiply the sign, negative, positive, negative. So remember, we want the region where we are getting a positive sign because we want the expression to be greater than. So domain will be 0 to 1. Next example. So now it has two pieces. One is has the square root and the other one is the logarithmic function. So remember, with the domains in chapter 2 we learned there are three things or three warnings or three things that you have to be looking for. One is that if there is a denominator, you shouldn't have a 0 in the denominator, so you set it equal to 0, solve and throw those away. The logarithm, you just saw what we do, and the square root, so this is what we do. We take the quantity inside the square root and set it greater than or equal to 0 and solve it. So in this case it is a very simple one. Now for the logarithm one, take the quantity, set it greater than 0 and solve it. That's it. And now we combine the two and write our domain. So I can put them on a number line. Well, you can see already what the domain is going to be even without doing this, but if this is 2, this is 6, but these inequalities are telling us, first one is saying starting at 2, including 2, going to the right, everything on the right is going to be in the domain. And then on the second one, x is less than 6 means starting at 6, not including 6. If you go to the left, everything to the left. So if you notice, the overlap is going to be here. So the domain is next expression. So we have a logarithmic function on the top, and at the bottom now we have a radical function, and have a square root term as well. So we have to take care of like three things here. First, let's look at the log, and it doesn't matter in which order you do that. I have to have 2x plus 7 has to be greater than 0, which means 2x has to be greater than 7. Now at the bottom, under the square root, we cannot have negative numbers. But also, we cannot have the whole denominator to be 0. So I will try to see what. Well, I can see just by looking, but not always it will be this simple. So I have to solve this. So I'll square both sides. Give me 6 minus x, because I squared. So which means x is equal to 6 minus 4 or 2. So this is the value that I have to throw away. So this was negative 7, not 7. So we have negative 7 over 2. Somewhere here we have 2 and then somewhere we have 6. So the domain is basically between negative 7 over 2 and 6, but we have to throw away the 2. So the domain so this is how we find the domains. Well, next one is exactly similar as part D, so I will leave it for you to do it. Looking at the next example, it's asking us to find the composition of functions. So these like exponential and logarithmic function with the composition with some polynomial here. So first thing is f composed with g of x. Now note here, please try to understand what this symbol means. Some people are thinking this circle inside here is like multiplication. That is not correct. So this is a special symbol and has a special way of writing and meaning. So we read it as f composed with g, and we say this is the same thing as f of g of x, which means f of x squared plus 1, which means wherever I have x in f, that x will be replaced by x squared plus 1. That is the answer. Now the other way, g composed with f of x. So this will be g of f of x. Now in g, wherever you have x, you will replace it by the function f of x. So I get, so the g of x is x squared plus 1. So remember, this square is on x. X is being replaced by 3 to the x. The square just remains there. But now we should simplify. Powers get multiplied, so we get 3 to the 2x plus 1. So that is the answer. Looking at the next example, similarly, f composed with g of x is f of g of x. So will be equal to, so notice here, 2 times log of x whole cube minus 1. And that's how you will leave it. You will not try to remove these parentheses. You will not write it like 2 log x cube minus 1, because this is wrong. This is not the same thing as what we have. This is your answer. G composed with f of x. So it's g of f of x. So inside the g, wherever I have x, I replace by function f. So I get log of 2x cubed minus 1. That's it. Okay, so now you guys should be good to do 4.3D.